Hello students, hope you are doing very well. So as you all know that today we are going to practice the NEET PYQs, that is the questions that have been covered in the NEET examination previously. So let's start our topic NCERT chapter 2 Electrochemistry NEET PYQ part 1. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using the generative AI, which is experimental. So let's begin with our first question. This question is a NEET PYQ question and it is covering the NCERT section 2.5. The question says that the number of Faradays represented by F required to produce 20 gram of calcium from the molten calcium chloride is. So you have to tell the Faraday which you are going to require to produce this much amount or this much quantity of calcium from the molten calcium chloride. The atomic mass of calcium is given as 40 gram per mole. Okay. So this question has been into the NEET examination in 2020. The options provided for this question are 2, 3, 4 or 1. You got some time, try to solve this and then we will see that what will be the correct answer. Okay, let's see. So for this given question, the correct answer is option D, that is 1 Faraday. Okay, now let's see how the 1 Faraday we are going to require for the given question. So 1 equivalent of any substance is deposited by the 1 Faraday of charge. It is as per the Faraday's laws of electrolysis. So any quantity, like how much charge is passing of Faraday, how Faraday charge is passing through a solution is determined that how much equivalent of the electrolyte is discharging or charging in that particular solution. Okay, so 1 equivalent of any substance is deposited by 1 Faraday charge quantity. Okay, so 20 gram of calcium, we have already given that you have to produce 20 gram of calcium from the molten calcium chloride. Atomic mass is given. So if 1 equivalent any substance is deposited by 1 Faraday, then we have given the weight of calcium as 20 gram, which we want. So if you get the number of equivalents of the calcium, which is given by the given mass upon the equivalent mass. Okay, so number of equivalent you can identify, then you can simply identify the Faraday you are going to need in this process. So the number of equivalents is given by given mass divided by the equivalent mass for the calcium. Now, the given mass is given as 20 gram and equivalent mass of calcium will be atomic mass divided by the valency or the electron that it can donate or gain in that process of getting the calcium from the molten calcium chloride. That is valency, right? So equivalent mass of calcium will be atomic mass. Atomic mass is already provided in the question, which is 40 grams per mole. So 40 divided by the valency. Valency is given as 2. Okay, because calcium chloride is gonna dissociate into the calcium 2 positive. plus 2Cl negative, right? 2Cl negative, that means we have 2 chlorine each having 1 negative charge, and calcium 2 positive, that means calcium ion having the 2 positive charge. We are talking about the calcium, so valency here for the calcium or the electron which are donated or accepted during the process of getting the calcium from molten CaCl2 is 2, because it is having the 2 positive charge, that means it has loosened its 2 number of electrons. So we are taking valency as 2 here. So equivalent mass of calcium will become 40 divided by 2. So 2 times 20 is 40. So that is 40 by 2 is 20. Okay, you just have to divide the 40 by 2. So answer is 20. 20 is the equivalent mass. You can put this equivalent mass into this formula. So given mass is already 20 gram given for the calcium. Equivalent mass we just identified as 20. So 20 by 20 is 1. That means the number of equivalents of calcium is 1, which we are going to produce from the molten calcium chloride. So the number of Faraday which we are going to require in this process will be 1 Faraday. Okay, 1 Faraday of charge is required to deposit 1 equivalent of calcium, because it is already cleared in the very first line that 1 equivalent for any substance is deposited by 1 Faraday amount of charge. That means if we are applying 1 Faraday charge, that will going to deposit the 1 equivalent of any substance. Okay, simply we have already given the weight of the calcium. You just have to derive the number of equivalents from this given weight. Atomic masses you already know for the calcium and also given already in the question. So number of equivalents if you identify, then you can apply the unit method and determine that how many Faraday of charge you will going to require. Because the number of equivalent has came as 1, so 1 equivalent of any substance will deposited by 1 Faraday. So 1 Faraday of charge is required in this process of deposition of calcium, which is also 1 equivalent from the molten calcium chloride. Hence, the correct answer is option D, that is 1. Okay, coming to the slide, so let's move to our next question. Okay, so this is a NEET PYQ question, and this is covering the NCERT subsection 2.2.1 in the chapter Electrochemistry. Question is asking that standard electrode potential for the SN4 positive, that is tin4 positive to tin2 positive couple, is 0.15 volt, which is in positive. Okay, so standard electrode potential for this couple is 0.15 volt, and that for the chromium 3 positive to chromium couple is minus 0.74 volt. These two couples in their standard state are connected to make a cell. Cell potential will be. Try to understand the question first of all. So this question has been into the 2011 NEET examination. The question is saying that first of all we have given the two couples, the tin and the chromium one. Their standard electrode potential are also given in the positive and the negative, their value, their magnitude, right? Now we have said that these two couples are joining together in their standard state. They connected together to make a cell. To perform a particular reaction, you have to tell that what is the potential of that cell. Okay, so you have to determine the cell potential. The 4 choices given for this question are positive 1.19 volt, positive 0.89 volt, positive 0.18 volt, or positive 1.83 volt. You have some time, try to solve it, try to analyze this, and then we will see that how you can solve this and how which option will be the correct answer. Okay, so let's see. So for this given question, the correct answer is option B, that is positive 0.89 volt, which is the cell potential for the cell which is made by the connection of the two given couples. So the couple for which the standard reduction potential value is high will act as cathode, on which the reduction process happens, and the other couple that is having the standard reduction potential lower will act as anode, at which the oxidation will happen. Okay, so first of all, when you are joining the two couples together to make a cell, that cell is going to have one cathode and one anode as their electrodes on which the charge will deposit or come out from. So at the cathode particularly, the reduction process generally happens, and at the anode the oxidation process generally carry on, right? Oxidation means, if you go in the basics, oxidation means the release of electron, and the reduction means the gain of electron. This is the very basic definition for the oxidation and the reduction, which we are using in this chapter, electrochemistry. Other than that, we have various definitions for explaining the reduction and the oxidation process. So at the cathode, as I said, generally the gain of electrons or the reduction process happens. At the anode, generally oxidation happens. Okay, so standard reduction potential as per the electro chemical series, if you have studied in this chapter, if you cover the theory part, we have their every reaction written in that table, and their standard reduction potential is given for that particular conversion of the ion to the reduced form. Okay, so there was the reaction where oxidized form we are taking, we are adding the required amount of electron to the particular ion, and then we are getting the reduced form of that ion. Okay, that was the reaction given in that table, and their standard reduction potential are always given in a order. Okay, increasing to decreasing or decreasing to increasing. So the couple given in this question are 10-4 positive to 10-2 positive, and chromium 3 positive to chromium. So what we are saying, that the couple which are having the standard reduction potential value high, which is for this case, tin case, because it is having positive 0.15, the other one is having negative 0.74. So that means the tin will act as the cathode, this couple will act as cathode, and the other couple will act as anode. So if you know the concept, the E naught of the cell, the standard potential, or you can say the cell potential, is defined as the E naught of cathode. That means the standard reduction potential of the cathode minus the standard reduction potential of the anode. Okay, so cathode minus anode was the concept we used to determine the cell potential. Simply, we both have cathode and the anode electrode potential, electrode potential, right? So we simply put out the value. So the simple task is in this question is that to identify that which couple will going to act as a cathode and which couple is going to act as anode. If you clear on that, then you will apply this formula simply, and by putting the values you can get the cell potential value. So E of cathode will be of 10, so 0.15 volt, minus E of anode is for chromium, so minus of 0.74, so minus of 0.74 volt. Now this minus multiplied by minus becomes plus, minus plus. These two quantity will going to add up, and the final cell potential coming out as 0.89 volt in the positive, and hence this will be the value of the cell potential, and hence the correct answer will be option B, that is 0.89 volt. Okay, so let's see our next question. Again, this is a NEET PYQ, and this is covering the NCERT section 2.5 in our chapter Electrochemistry. The question is saying that equivalent conductance of M/32 solution of a weak monobasic acid is 8 8.0 mole centimeter square. What we are saying, that the equivalent conductance of this much of molar, that is m by 32 molar solution of a weak monobasic acid. We have a solution of weak monobasic acid whose concentration is this much and whose equivalent conductance is 8 mho. Mho is basically ohm inverse. Okay, you can write the ohm inverse as MHO, centimeter square. And at the infinite dilution, the equivalent conductance is 400 mho centimeter square. The dissociation constant of this acid is, so you have to identify the dissociation constant for this particular weak monobasic acid. This question also has been in the 2009 NEET PYQ NEET examination. So try to remember the concept of equivalent conductance and how you can relate it with the concentration, right? And the dissociation constant, how can you get the dissociation constant from the equivalent conductance? Then you can solve this. So we have 4 choices given, which is 1.25 times 10 to the power minus 6, 6.25 times 10 to the power minus 4, 1.25 times 10 to the power minus 4, or 1.25 times 10 to the power minus 5. So these are the 4 options. You have to select the correct one. You got some time, try to solve it, and then we will see that which option is the correct answer. Okay, let's see. So for this given question, the correct answer is option D, that is 1.25 times 10 to the power minus 5. Let's see how. So the question was that you have to identify the dissociation constant of the acid. Dissociation constant, right? If you remember, dissociation constant is related with the degree of dissociation represented by alpha. How? Let's see. So degree of dissociation is given by lambda equivalent divided by lambda equivalent infinity, or you can also write it, you also know this formula as alpha equals to lambda m molar conductivity divided by limiting molar conductivity, remember, right? So simply we have write in the place of molar equivalent. Okay, we have write the equivalent at the place of molar. So the alpha is defined as equivalent conductance divided by the limiting equivalent conductance. Okay, now the both values are given. Okay, so basically the equivalent conductance is given as 8 mho centimeter square, right? This much. So we write it as 8 divided by the limiting equivalent conductance, that is the equivalent conductance at infinite dilution is 400 as given. So we write it as 400. Okay, infinite dilution as the sign says. When you solve this fraction, 8 divided by 400, you will get 2 times 10 to the power minus 2 as the answer. So this is the value of alpha. This is the value of alpha, which is degree of dissociation. Now the dissociation constant, that is Ka, in the terms of alpha it is defined as C alpha square divided by 1 minus alpha. Alpha here is representing the degree of dissociation and C here is representing the concentration. Concentration, concentration is this, already given in the question, right? Now we are taking this whole quantity of the Ka of the dissociation constant as equivalent to C alpha square. That means only the numerator part. Why? Because in the denominator we have 1 minus the alpha. Alpha value is coming out in the 10 to the power minus 2. That is very less. 2 times 10 to the power minus 2 in compared to 1. So if you subtract something from the 1 which is this much less, you can just ignore it, right? And at the place of that you can write at the denominator only 1, right? So we are taking this whole quantity as C alpha square by 1. We are ignoring this alpha value because it is very less. When you subtract it from the 1, it will not make as such difference. So C alpha square, C as I said is concentration is given as 1 by 32. Okay, why I am saying 1 by 32? Because if the solution is given as 2 molar, let's say, we take its molarity as 2, right? If we are saying that the solution is 6 molar, we are taking its molarity as 6 or concentration as 6. But we have given the molarity as m by 32. That means we have to take the concentration or molarity as 1 by 32. The concentration and molarity term both are same. So that's why we are taking here C as 1 by 32 multiply by alpha square. Alpha value is this much we have calculated. So 1 by 32 multiply by 2 times 10 to the power minus 2 whole square. Okay, and you just have to solve this quantity to get the dissociation constant. So Ka is finally coming out as 1.25 multiply by 10 to the power minus 5. Okay, after solving this you get this answer, which is the value of dissociation constant, and hence the correct answer is option D. Okay, so let's move on to our next question. So this is a NEET PYQ, and this is covering the NCERT section 2.5. The question is saying that standard reduction potentials at 25 degrees Celsius of lithium positive to lithium, barium 2 positive to barium, sodium positive to sodium, and magnesium 2 positive to magnesium are minus 3.03, minus 2.73, minus 2.71 and minus 2.37 respectively. Okay, so for each couple their respective standard reduction potential value is given, right? Which one of the following is the strongest oxidizing agent? So you have to tell by looking the standard reduction potentials value that which couple will be the strongest oxidizing agent, which ion will be strongest oxidizing agent. So the options given are sodium positive, lithium positive, barium 2 positive, or magnesium 2 positive. So for solving this question, try to remember the standard reduction potential concept, and you got some time, try to solve it, and then we will see the correct answer. Okay, let's see. So for this given question, the correct answer is option D, that is magnesium 2 positive. How? So higher the reduction potential, if the reduction potential is higher for a particular ionic reaction, okay, stronger is the oxidizing agent. Okay, higher the reduction potential, stronger will be the oxidizing agent. That means strongly or more powerly or more efficiently it can oxidize other get reduced itself. That's the concept of oxidizing agent. So if the reduction potential is higher, that means it can easily be reduced or it can easily oxidize the others. That means it will act as stronger oxidizing agent. Now among the given values, if you compare minus 3.03, minus 2.73, minus 2.71, minus 2.37, if you arrange these in the order of increasing value, the lowest is minus 3.03, right? If you know this is so basic that in the negative term, as the value increase, its overall magnitude is going to decrease, right? So minus 3.03 is lesser than the minus 2.73, and this is lesser than minus 2.71, and this is lesser than minus 2.37. So minus 2.37 is the highest value given, right? So this is the highest reduction potential for the magnesium, which is given for the magnesium. So magnesium reduction potential is highest. That means it can be easily reduced or it can easily oxidize others. Inversely, you can say that, right? That means it will act as stronger oxidizing agent. So among the given values, minus 2.37 volt, which is for magnesium, is the highest one. That means it is the least negative value. That is why the magnesium is going to be act as the strongest oxidizing agent. Okay, also the question is asking that strongest oxidizing agent you have to tell after looking at the standard reduction potential values for different ions given. So we have the correct answer as option D, that is magnesium 2 positive. Okay, now let's move on to the next question. Okay, so this is a NEET PYQ question and this is covering the NCERT section 2.5. The question is saying that at 25 degrees Celsius, the molar conductance of 0.1 molar aqueous solution of ammonium hydroxide is 9.54 ohm inverse centimeter square mole inverse. So we have given the molar conductance, that is lambda m, of this much concentration aqueous solution of ammonium hydroxide NH4OH. So the molar conductance value is 9.54. And at the infinite dilution, its molar conductance is 238 ohm inverse centimeter square mole inverse. The degree of ionization of ammonium hydroxide at the same concentration and temperature is. This time you don't have to tell the degree of dissociation, but you have to tell the degree of ionization of ammonium hydroxide at the same concentration, which is 0.1, and at the same temperature, which is 25 degrees Celsius. That means at the same conditions, you have to tell the degree of ionization using the given data already in our question. So this question has been into the NEET examination in 2013, and the 4 choices given provided for this question are 20.800%, 4.008%, 40.800%, or 2.080%. Okay, so using the given concept and the given data, try to solve this and then we will see that which option will be the answer. Okay, so let's see. So for this given question, the correct answer is option B, So yes, very good. The correct answer is option B, which is 4.008%. So as you know that the degree of dissociation is defined as lambda m divided by lambda infinity m. We just have discussed about this, that alpha is defined as the molar conductivity divided by the limiting molar conductivity, or you can say molar conductivity at infinite dilution, right? Both the values are given. So the molar conductivity is 9.54. We put the 9.54, and at infinite dilution molar conductivity or molar conductance is 238, so we put the denominator as 238. Simply have to divide it and write it equals to 0.04008. But here the trick, that the options are provided in the percentage. Okay, so whatever the answer you are getting, don't in a hurry, don't just mark anything. Try to resolve this into the percentage form. How? By divide it, or you can say multiply it. You can do anything by divided by the 100 for the conversion of the percentage, right? So it will become okay. So if anything is already in percentage, you can define it as that something divided by 100, right? If something you have to convert into the percentage form, then you have to multiply by the 100. Okay, so when you multiply, it will be 4.008, and you put the sign of percent. It already indicates that you have to divide this quantity 4.008 by 100 to convert into a simple quantity, which is the original answer. But for the conversion of original answer to the percentage, you have multiplied it by the 100 and get the quantity in the percentage. So the correct answer, which is matching with the given percentage, is option B, which is 4.008%. Right? So this is how we have calculated the degree of ionization for the ammonium hydroxide, given their molar conductance and the molar conductance at the infinite dilution, using the degree of ionization. Okay. Okay, so let's move on to the next question. Now this is again a NEET PYQ, and it is covering the NCERT section 2.5. The question is saying that copper in the aqueous form is unstable in the solution and undergoes simultaneous oxidation and reduction according to the reaction this. Okay, we are saying that copper in the aqueous state is unstable, it is not stable in the solution, and it is also undergoing simultaneous oxidation and reduction at the same time. Simultaneous means at the same time it is undergoing the oxidation and the reduction process according to the reaction 2 copper positive, giving us copper 2 positive plus copper. So if you see, the copper in the +1 state is going to the copper in +2 state, that means the oxidation is happening, and copper is +1 also going to copper in the 0 oxidation state, that is 0 charge, neutral charge, that means it is going from +1 to 0, that means reduction, right? If you go on the basic definitions for the oxidation reduction, so if oxidation number is just charge is increasing, that means oxidation is happening. If it is decreasing, that means reduction is happening. So here the oxidation reduction both are happening simultaneously. Now you have to choose the correct E0 value for the above reaction. If the E0 of copper 2 positive to copper is given as 0.34 volt and the copper 2 positive to copper positive is given as 0.15 volt. Using these two quantities, you have to choose the correct E0 value from the given options. So this question has been in the 2000 NEET examinations. The options provided are minus 0.38 volt, plus 0.49 volt, plus 0.38 volt, or minus 0.19 volt. You got some time, solve it and then we will see that which will be the correct option. Okay, let's see. So for this given question, the correct answer is option C, that is positive 0.38 volt. So this is the reaction given, which is 2 copper positive converting to the copper 2 positive and also to the copper in the neutral state. So if you divide this reaction, if you can say take the one part of the reaction, that means oxidation different and the reduction different. So copper 2 plus gaining 2 electrons, becoming copper in the neutral form, and its E naught value is given as 0.34 volt as per this E naught value, right? So we have written this equation or this reaction by using this E naught. So this conversion of copper 2 plus to copper by gaining 2 electrons has the E naught value, which is marked as E naught 1 equals to 0.34 volt. Let's say this is the first equation. Similarly, for the copper 2 positive, by gaining 1 electron becoming copper positive, the E naught value marked as E naught 2 is equals to 0.15 volt as also given in the question, right? Let's say this is second equation. Now copper plus, when gain 1 electron becoming copper, then we don't know that what is the E naught value for this, right? Because if you see the question, it is given that copper is unstable in the aqueous form and it is going the oxidation and reduction process simultaneously according to the given reaction. You have to choose the correct E naught value for this given reaction. If this reaction E naught is this 0.34 volt and the second reaction marked as second reaction E naught value is 0.15 volt, that means the only process which has remained is copper positive to copper conversion, this copper positive to copper conversion as per this reaction, right? So this reaction E naught we don't know, that means E naught 3 is question mark, that means we don't know. So this we have to find out. So let's say this is third equation. Now we know that free energy for a reaction is defined as delta G1 naught equals to minus NF E1 naught, right? We know the N for the each reaction, and the F value, let's say it is F only, let's put it as F because it has a constant value, and E1 naught we already know, which is 0.34 volt, right? So for the first reaction, the del G1 naught equals to minus NF E1 naught, right? N is 2. Why we are taking 2? Because 2 number of electrons are involving in this reaction. So N is 2, minus is already present, multiply by E1 naught, which is 0.34 volt, multiply by Faraday. Faraday has a constant value, that's why we are writing it as F. Similarly, for the second question, the delta G2 naught will be minus 1 because only 1 electron is there. So minus 1 multiplied by 0.15 Faraday. 0.15 is the E naught value. 0.15 times Faraday. And similarly, the delta G3 naught value, that is minus 1 because 1 electron is involving in the reaction third. So minus 1 multiplied by E naught 3 because E naught 3 we don't know, multiply by Faraday. So these are the 3 G values, that is the free energy values for the 3 reactions, first, second and third. Simply, you know that delta G1 naught will be equals to the delta G2 naught plus delta G3 naught. Okay, G1 naught means this first reaction. This will be the sum of the delta G2 and delta G3. Delta G2 is for the second reaction, delta G3 is for the third reaction. Okay, because you know, when you join this will be the first reaction. Okay, because electron, 2 electron will form, because both the electrons are at the same side of the arrow. That's why we are adding them. So they will become 2 electrons. This copper 2 positive will also came as it is. This copper positive and this copper positive is present at the opposite sides of the arrow, so they will cancel out, and this copper positive will remain as it is at the right hand side of the arrow. So the sum of the second and the third reaction will become equals to the first reaction. That's why we are writing that delta G1 naught equals to delta G2 naught plus delta G3 naught, and we have the every G values, so we simply put it. So minus 0.68 Faraday equals to minus 0.15 Faraday minus E03 Faraday, right? Now Faraday is a constant, so we can simply take it common at the right hand side and cancel it out with the Faraday present in the left hand side, right? The remaining term only variable is E03, and other than that only numerical terms are present. So simply you can sum up or then subtract the terms to get the E03 value. So E03 will be 0.68 minus 0.15. This will be equals to 0.53 volt. Now this is the E0 of 0.53 volt. Okay. Now E0 of cell, the E0 is, you have to determine for this cell reaction, the complete cell reaction in which oxidation reduction both are happening. So E0 of cell will be E0 of cathode, which is copper positive to copper, minus E0 of anode, which is copper 2 positive to copper positive. Now this E0 value we have already provided in the question, but this E0 of cathode we haven't provided in the question. That's why we done this much calculation. Okay, as now we have E0 of cathode, which is E0 of 3. So E0 of cathode will be 0.53, this much we just have calculated, minus E0 of anode. Anode is given 0.15, so minus 0.15, and when you subtract these two quantities, they are equals to the positive 0.38 volt. Okay. Okay, so let me explain again that how this delta G1 naught equals to delta G2 naught plus delta G3 naught, right, as per the question. So basically, first of all, we know that this equation is given, this reaction is given, in which oxidation reduction both are happening. How we identify? The oxidation number is changing. Okay, now we divide this reaction by or as per the given E0 values. Okay, this E0 value is given from copper 2 positive to copper value. So copper 2 positive is becoming the copper by gaining 2 electrons, and we are calling it as first equation. Okay, now copper 2 positive is going to copper positive. So copper 2 positive, let me use the other color, let me use purple color. So copper 2 positive is becoming copper positive. Its E0 is already given, right, and we are saying it as second equation. The remaining equation or the remaining conversion as per this reaction given is copper positive is converting to copper, because here the copper positive is converting to the copper in the main reaction, right, but we haven't divided the reaction as like that. So for this conversion also we have to get the E0 value, which is not given in the question. Okay, the 2 E0 value given for the reactions we derived or we write it, but for the E0 3 we have to count it or we have to calculate it, that what will be the E0 3. So that's why we are writing here copper positive converting to the copper and have the E0 3 value as this for this conversion. Okay, but we don't know E0 3, so we have to identify first of all this, and we are calling it as third equation. Now focus what I am saying, that delta G1, which is for first, one is representing first equation, second is representing second equation, third is representing third equation. We are saying that delta G1 is delta G2 plus delta G3. That means we are adding second and third are getting the first equation. Okay. So if you add the second and the third equation, which is electron plus copper 2 plus giving us copper plus, this is our second equation. Now if you add it with copper plus electron giving us copper, that is our third equation. When you add the second and third equation together, what you will get? So this copper positive is already present at the right hand side also of the arrow, so it will cancel out. Okay, the remaining thing will add up. So one electron at the same left hand side of the right arrow they are present, that's why we add them. So they will become 2 electron plus the copper 2 positive, right arrow, copper, right? This is the reaction we get after adding the second and third reaction. If you compare this with the first reaction, they are same. It is exactly the first equation, 2 electron plus copper 2 plus giving us copper, right? That's why we are saying that delta G of 2, that is second reaction, delta G of 3, that is third reaction. When you sum them, that will be equals to the delta G of first reaction. Okay, so that's why we got this relation, and that is how we get the E naught of cell, that is cell potential, after getting the E naught of cathode, and the final cell potential is 0.38 volt, and the correct answer is option C. Okay, let's move on to the next question. Now this is a NEET PYQ, and this is covering the NCERT section 2.5. So question is saying that in electrolysis of sodium chloride, when the platinum electrode is taken, the hydrogen is liberated at the cathode, while with the mercury cathode it forms sodium amalgam. This is because, so you have to tell the reason, that when you are doing the electrolysis process of sodium chloride and you are taking the platinum electrode, then hydrogen is liberated at cathode. But if you are taking the mercury cathode, it will form sodium amalgam instead of the hydrogen. Why this happens? So you have to tell the reason. This question has been in the 2002 examinations of NEET. So the given 4 options provided are: mercury is more inert than platinum, more voltage is required to reduce the H positive at the mercury than at the platinum, sodium is dissolved in the mercury while it does not dissolve in the platinum, or concentration of H positive ions is larger when the platinum electrode is taken. Okay, so you got some time, try to solve this and try to find out the correct reason. Okay, and then we will see that which will be the correct answer. Okay, let's see. So for this given reaction, okay, so for this given question, the correct answer is option B. That is, more voltage is required to reduce the H positive ions at the mercury cathode than at the platinum electrode. Okay, so that is the correct reason. So if mercury is used as cathode, that is if you use Hg as cathode in the electrolysis process of the sodium chloride, H positive ions are not discharged at mercury cathode. Why? Because mercury has a high over voltage for the hydrogen. It should have high over voltage for the hydrogen, you can say, discharge. Okay, so it should have higher voltage to discharge the H positive ions. That's why we are using the platinum electrode and then hydrogen is liberated at cathode, but not in the case of mercury cathode. Okay, so we are talking about the electrolysis of the sodium chloride, right? And we are saying that in this process the electrode we are taking is platinum, where the hydrogen is liberated at cathode. And if you take the mercury as a cathode, it forms the sodium amalgam. Okay, that means sodium amalgam means HgNa something. Okay, so why this is happening? Because if the mercury is used as cathode, the H positive ions, the protons, are not discharged at the mercury cathode, because the mercury will be having the higher over voltage for the hydrogen discharge. Okay, so as per this given question, the correct reason why we are not considering the Hg cathode, that more voltage is required to reduce the H positive at the Hg cathode than the platinum. At the cathode, we do the reduction process, right? We do the reduction process. So H positive is not going to reduced at the cathode in the case of Hg, that is mercury cathode, because it is needing more potential for that. But platinum has a lesser potential. It can easily reduce the H positive ions. That's why we use the platinum electrode here. Okay, so option B is the correct statement or correct region for this purpose or for this process. Okay, so let us move forward. Okay, this question is a NEET PYQ and this question is covering the NCERT section 2.5. So the question is saying that consider the half cell reduction reaction. We have given the half cell reduction reactions, these two. The Mn2 positive gaining 2 electrons, giving discharging 1 Mn or getting 1 Mn in the neutral form after the reduction. And the E naught for this process is minus 1.18 volt. When the Mn2 positive is discharging 1 electron and also converting to Mn3 positive, that means the oxidation reaction, its E naught value is minus 1.51 volt. So these are the half cells reactions given. The E naught for the reaction 3 Mn positive, Mn2 positive, giving us Mn0 plus 2 Mn3 positive. And the possibility of the forward reaction are respectively. So you have to tell that what is the E naught for this reaction by using these two half cell reactions and their E naught, and also you have to tell the possibility of forward reaction whether happen or not respectively. Okay, so the four choices given are minus 2.69 volt and no, minus 4.18 volt and yes, plus 0.33 volt and yes, or plus 2.69 volt and no. So you have some time, go through it, try to solve this, and then we will see the correct answer. Okay, let's see. So for this question, the correct answer is option A, that is minus 2.69 volt and no. So the E naught value, the delta E naught value is defined as the reduction potential plus the oxidation potential for a cell, right? So the reduction potential is minus 1.18 reduction process minus 1.15 the oxidation process. When you do the minus minus will plus, so when you have to add them, this will be minus 2.69. Okay, so this is delta E naught. Okay, delta E naught value. Now, since the delta E naught is negative for this reaction, okay, so what does that means? That del G is defined as minus NF E naught. Okay, E naught is negative. Negative and negative will become positive. That means del G will have positive value finally. So the forward reaction is not possible in that case. Okay, del G should be negative for the forward reaction, for the spontaneous reaction. Okay, del G, if it is having positive value, then the forward reaction is not possible. So that's why we have saying no. And the value of electrode potential of a half cell reaction does not depend on the stoichiometric coefficient. Okay, whatever the stoichiometric coefficient you will put, the value of electrode potential for a half cell will not going to change. If you take the example, like if you take Mn2 positive converting to Mn3 positive and electro plus electron, the E naught will be minus 1.51 volt. And if you take twice of Mn2 positive, giving us twice of Mn3 positive plus twice of electron, the E naught will remain same. So the stoichiometric coefficient will not going to affect the E naught value for the particular half cell. Okay, so that's why we are saying that del G is going to have the positive value here due to the negative value of the E naught, and the forward reaction, that's why not possible, because E naught is negative, so negative will become positive and del G will be going to positive. Del G should have to be negative for the forward reaction. Okay, so the correct answer is option A, that is minus 2.69 volt, and the forward reaction, that is answer is no. Okay, so okay, thank you so much for joining this chemistry session.